All right, well, thank you very much. I appreciate you all being here today. And I'm excited to talk to you today about our collaboration with SK Telecom and how we collaborated to fine-tune the Claude model for their contact center use cases. So the format today is going to be a little bit different. I did expect to have Eric here with me today, but unfortunately Eric couldn't make it. So Eric has kindly recorded his part of the presentation and we'll be segueing into that, and I'll do some intro and context on the industry, the use case, and what Eric is going to talk about. So as said, we're going to change it a little bit. I'm going to go through the agenda here. I'll set up the situation, as I said, the context, talk about the use cases. But this is going to be a really interesting session. If you're interested in the process, the challenges and the benefits of fine-tuning large language models for these use cases. And we call these, we'll talk about this during the presentation, but we call these high-value workflows. So areas that we can really apply generative AI to get a step function increase in value delivered. So I'm going to kick this off by framing the telco industry and the contact center, because really that's the initial use cases that SK Telecom are focused on. So like many industries, telco customers are looking for telcos to meet them where they are. So that means to provide a service anytime, any place, anywhere, and really any modality, right? So that would be chat, that would be the physical retail store, whatever it may be, we need to meet the customers where they are. But within telcos specifically, the main touch point and the main way to interact with telcos is still with phone calls. So about 80% of interactions are customers picking up the phone and calling the contact center. And for context, when we start looking at, let's say, for example, tier 1 operators in North America, you're looking at about 1 billion interactions per year. And that's driving up voice minutes in the billions. So about 4 to 5 billion minutes of voice are actually being processed through contact centers in North America. So the scale is massive. And with that scale comes huge opportunity to optimize and start doing some significant customer experience improvements, as well as reducing the cost. But these high volumes are actually an opportunity, because within the context of telco calls into customer care, generally about 60 to 70% of those are billing or account related. So that means these are common interactions, common intents that we can actually map, understand, and start to automate. And that's some of the things you're going to see here when we use the adapted models to start understanding those kind of intents and context. The other thing is that the expectations from customers are now higher than they used to be. Like, there's the expectation of personalization, there's the expectation of us knowing what customers want and helping them through that journey. And frankly, that expectation has been driven up by digital natives like Amazon, who really have focused on the web experience, removing the friction from the interactions. So expectations as a result across all industries have been driven up. So we talked about there's lots of calls, there's lots of different channels of interaction, and I would argue that in telco that's probably more complicated than many. We have physical retail, so people walking in off the street, people chatting, people on phone calls, people on the web, people on their mobile phone through apps. And it's really difficult to actually tie that all together to understand the customer journey of when that journey is good or when that journey is bad. So you can see that telcos broadly are not meeting those expectations, right? You know, feedback is showing that there are long wait times, that people are visiting retail stores and dropping out because there's not enough resources to actually service them. So what we're trying to do broadly is tie that all together and understand how how we can actually improve that experience. And there is also a move in contact center away from it being a cost center, which is just fielding customer issues, to actually being a profit center. So there was a McKinsey report recently that the expectation is that up to 60% of incremental revenue, future revenue, will be driven through contact center interactions. So those interactions are seen as an opportunity to cross-sell and upsell. And again, some of the telcos we work with are actually starting to put metrics and goals on the number of calls that are upsold within those contact centers. So there are new goals that are actually being established to improve that experience. So now I'm going to cut over to Eric, who's going to kind of frame why they're building a large language model for the contact center and what that really means to SK Telecom.
My name is Eric Davis, and I am the VP of the AI Tech Collaboration Group at SK Telecom. I've been at SK Telecom for 6 years now, and I have led various natural language processing projects. Recently, I've come under the purview of the Telco large language model, which is a model we built in collaboration with Anthropic and AWS. And I'm really excited to tell you this story because one, it was a huge collaborative effort involving lots of teams and lots of people. And two, it led to a lot of innovation in the telco industry. So happy to be here and very looking forward to presenting this fantastic topic. The first topic we're going to talk about today is the need. Why do we actually need to build this telco large language model? You've probably seen other companies say we just prompted ChatGPT and we're able to release a product. At SKT, we obviously tried that at first, but we realized that it did not meet our needs. And so why did we need this model? Large language models are fantastic. I want to emphasize that. But at the same time, they are a jack of all trades and a master of none. So if I want to learn about Greek poetry, I can have a model spit out Greek poetry. In our case, the use case was much more specific. We wanted to focus on the telecommunications domain. What are the tasks in the telecommunications domain? What are the needs? And so we ended up having to tune a model to meet these needs. One, understand products and services. And so for us, when users call in or when users interact, they have a lot of questions about products and services. So being able to recognize what these products and services are, understand them, understand what the plans are, is super, super important for us. And a base model does not provide that out of the box. Number two is we do a lot of product recommendation and selection. People will call in and ask questions. Tell me about the new iPhone 16. Tell me about this various plan. Again, base models sort of recognize these, but not at a deep level. We needed a deep level of understanding both of our customer and the actual product and service so we can recommend and select proper products for our customers and when they call in and ask. The third one is, again, intent. We get a lot of calls or a lot of chat messages. People have issues they need to troubleshoot. Being able to understand these intents and take actions is also very, very important. And also, again, something that the base model does not support out of the box. And so for these reasons, we ended up tuning a base model with Anthropic to really support these three key tasks for our use cases at hand.
So when we start thinking about the application of generative AI to the telcos that we work with, there's been, let's say over the last year, the move to POC and experimentation. And now there's this real move to try and generate value from generative AI. So move from POC into production. Now, at the end of the day, generative AI does not deliver any value until you're really implementing production workloads. So what we're now advocating for our telcos based on working with telcos, listening to them, is that as you start applying generative AI to your business, you should focus on what we call high value workflows. So these are workflows that are carrying revenue, cost, customer satisfaction that are primed to be optimized. And we see that these high-value workflows can be optimized with customer data and fine-tuning these models really in the context of that high-value workflow. So because of that, what we're seeing is that because we're adapting these models and they're specialized to these very specific workflows, we're seeing a step function increase in value on those workflows when you apply generative AI to it. And we'll talk about some of these explicit kind of metrics that we look to improve and why they actually improve the experience and ultimately improve the cost profile as well as the performance of the models. So we're going to move into a section where Eric's going to start talking about fine-tuning the Claude model using their data. And he's going to start talking about some of the value that has been delivered as part of that. Now, the Anthropic models, the only place you can actually fine-tune an Anthropic model in a managed service is AWS currently. So we're very proud of what we've built within Amazon Bedrock to actually enable that. And put simply, what we're doing and what SK Telecom have done is take their data. In this context, it's labeled data, focused on the domain. In this context, it's the contact center. And then we use that to fine-tune the model. And what that broadly means is that we're updating the weights of the model with the new information. So we're incrementally adding information so that the model understands the semantics, the context, the language that's being spoken in the context of the industry. For SK Telecom, there's also the further complication that this is Korean. So most frontier foundation models are predominantly English. So a lot of this was around using Korean language also to kind of fine-tune the model, right? So that makes the, I think the outcomes that SK Telecom achieved even more impressive. So let's hear from Eric how and why SKT did this and some of the outcomes.
So now that we know the reason why we need a Telco LLM, let me explain what the Telco large language model is. So again, every company under the sun has been building a large language model, but largely there's major players in the game. One is OpenAI, they had the first model in GPT. Another major player is Anthropic. And so at SKT, normally we try to build things internally, and we have for a number of years. On this slide, you can see we have our own model called A.X large language model, which I used to be in charge of. But our chairman came straight from the top and said we need to be an AI company, number one. We also need to be a global company. And from that point on, we started doing a lot more partnerships and collaborations with big tech players. So for this project, as I've mentioned, we partnered with Anthropic to build out what we're calling TelClaude. And so if you look at this, the whole point of the project was to adapt or optimize this base model for the telecommunications domain. And so we took a lot of in-domain data and did a lot of fine-tuning experiments with Anthropic to create this base telco large language model, which one is an expert in the telecommunications domain, and two can take action within that domain. Actions meaning doing some searches or calling out to APIs. Once we had this model, it became much easier to roll out use cases. And when I talk about use cases, these are things that we need to target internally. So the whole focus this year at SKT was on internal operational efficiency. How can we make our processes much more efficient? And so largely we focused on the call center, and we focused on touching our customers in various different touch points. For example, chat or voice or multimodal. And so once we had this telco large language model, it became very, very easy to tune the model once again to support the relevant use case at hand. It gave us a very strong model, a very strong foundation, and it set it up very nicely for the future. That being said, once we've shipped these products and services, we get relevant data so we can keep updating the model. So I want to make this very clear. The model is not static. We keep updating the models to, again, better the user experience and better our own internal operations. So now that we've established what the Telco LLM is and why we need the Telco LLM, let's talk about the nuts and bolts of the Telco LLM. So again, you start with a base model, whether it's an OpenAI GPT model, whether it's an Anthropic model, that doesn't matter. But what makes the Telco large language model special is it looks exactly like this pyramid you can see on this slide. And so it's not just the model, it's not just the fine-tuned model, but it's a whole work our way up the stack, again, to make it much faster and easier to ship products and services. And so at SKT, we love pyramids for some reason. So our CEO outlined the AI pyramid strategy. Well, this is the strategy of a ready-made large language model, again, so we can basically take it and ship products and services faster and more efficiently. So if you look at the pyramid, the base layer is the base model. This is the model that works out of the box. Again, we purposely partnered with an OpenAI or Anthropic because we wanted to get to market fast. Then, as I said on the previous slide, because this model does not support the use cases of the task at hand, we did a lot of effort into fine-tuning the model. We could have rested on our laurels and said this is great, but we took it a few steps further. Aside from that, as I said, a lot of these models are very good at chatting, so that's perfectly fine, but we wanted to specifically take action. And so we spent a lot of time, how do we actually call out to APIs in the back end? How do we actually do retrieval? So that's where the tool layer comes in. Then aside from that, the linking with the backend systems was super important. We have a fantastic knowledge system, but if we can't tap into that with our telco large language model, we've missed the point. And so a lot of integration work was done tapping into our knowledge-based system. How do we find relevant facts? How do we surface these relevant facts to the end user? That was the next step. Aside from that, we get a lot of complex queries, so orchestration was also super, super important. Orchestration is, how do we route this query to the right backend system? How do we actually answer this query? And so again, it's not just a dumb pipe, it's a smart router or smart orchestration that routes the query to the right backend system and the right actual task at hand. And then the syntactic sugar on top was the prompt engineering. We spent a lot of work with Anthropic on prompt engineering to make sure that we measured tone and style and format so we could surprise and delight our users. So the whole point of this slide is, again, it's not just the model. Think of this as more of an ecosystem where we're working our way up. So it's now ready-made, and again, we can ship our products and services to market much faster and much more efficiently. So it's a win for us internally at SKT and a win externally for our end users and customers. So we had the model. You're probably wondering about sort of what are the advantages? How are we actually saying is this model better than the base model? So it's very easy to look at performance. That's perfectly fine. At SKT, we like to go the extra mile. So this is patent pending, but we have something called the Telco LLM capacity index. And so this index measures three things that we find important when we're actually evaluating the performance of this model. One is, not surprisingly, performance or expertise. How good is this model at understanding and taking action within the telco domain? And so for this is also patent pending. We're calling it the telco expertise score. And so it's an overarching score of, again, how well this model does on key tasks in the telco domain. Aside from that, the whole point of this model, again, was efficiency. So we're looking at two things. One is speed. These models are notoriously big, and so they're slow. And so by tuning and optimizing serving, we wanted to increase the speed, make sure that we can surface answers faster. Aside from that, though, cost is a huge issue. These models have gotten much, much cheaper, that's true, but if you're surfacing millions of inquiries, these get really expensive really quickly. And so we wanted to optimize costs as well. And so we did that by basically optimizing the input and the output, so you reduce the number of tokens, meaning the cost is now optimized. And the third one is the development period. So as I said in the previous slide, the whole point of having a ready-made model is to reduce time to market, to get products and services out as fast as possible. And so we're measuring pre and post. Pre this model, how long did it take to go from zero, as in there's no service, to a fully fledged service? And after this model, how long did the same process take? And we're measuring percent improvement in efficiency. And so these are the three key indicators about how well this model is actually doing, how well we're applying this model, and how much cost saving we're actually seeing from tuning this model with these big players I've mentioned on previous slides. This is a very tightly knit co-development process. And so there's four major steps here. Obviously, SKT knows the language, not surprisingly. We also know the telco domain. So in this process, we are in charge of actually constructing the data. So my homework from last year was, what does a telco LLM actually mean? And so I thought long and hard. I worked with my fantastic linguist team, and we defined key tasks and key data sets that we used to tune the model. So that was step one in this diagram. The second step is, obviously, if we have fantastic data, we should probably do some fine-tuning. And again, we could have done this internally. We did, in fact, tune our A.X LM, but to get to market faster, this is why we worked with Anthropic. They're experts in modeling, they're experts in fine-tuning. And so the second aspect here was the fine-tuning. This was done by Anthropic. They were responsible, but we gave them input in terms of how do we actually mix the data, how do we weight the data. So this is truly collaborative as well. The third process, and this makes Anthropic unique, is RLHF. Reinforcement learning from human feedback. This is the secret sauce that put ChatGPT from good to great, that made people fall in love with it. And so Anthropic actually offered this service. And so we spent a lot of time collecting preference data and really honing and optimizing our model to respond how our end users wanted these responses. That was the third step. And the fourth step, again, comes back to SKT, but largely we're experts in the domain, we're experts in language, so we're responsible for benchmarking. How good is this model? What are areas for improvement? What do we actually need to do to push this model completely over the edge? So that was the process, that was the 4 steps. I want to call out this as a very iterative process. We didn't just do one cycle and say, good, we're done. We did many different cycles. So think of each iteration lasting about 2 weeks. And so over the course of the year, if you do the math, which I'm very bad at math, but it works out to about 24 different iterations we were able to do over the year, which took the model from okay to fantastic and very shippable. So very proud of this work.
Okay, so now we're going to start to cover some of the collaboration perspectives that we had between SK Telecom, Anthropic, and AWS. So AWS has got a program called the Generative AI Innovation Center, where we have a bunch of smart data scientists, data strategists, or strategists that work with our customers to help them accelerate their generative AI journey. So that's building proofs of concept, that's helping them with the strategy, it's guiding them with use cases and use case roadmaps, so on and so forth. There's a couple of capabilities within the Generative AI Innovation Center. One is the model customization program, which essentially is a program dedicated initially to fine-tuning Anthropic Claude models. So we developed a fine-tuning API, and our generative AI innovation people would come in and work with customers to fine-tune those models. And that's part of what we did with SKT, and we worked in collaboration, a three-way collaboration with Anthropic and SKT to kind of achieve these outcomes around the fine-tuning and also some of the components around optimizing the RAG, or the retrieval augmented generation. Generative AI Innovation Center has also evolved into fine-tuning on AWS Silicon. So you would have heard this week, we announced Trainium 2. So we have engagements ongoing with Inferentia Trainium, and then Trainium 2 will be coming obviously as well. So really focusing on helping our customers with the price performance components also. So this really just outlines the kind of collaboration between the three parties, the kind of roles, and really the kind of capabilities that they brought to the table. So obviously Anthropic with the Claude family of models, we believe one of the best frontier models out there. It's hosted in Amazon Bedrock. We collaborated obviously through the Generative AI Innovation Center as well as our Bedrock team to ultimately host the model in there, and then using our API in collaboration with Anthropic to fine-tune the model. Anthropic and SKT have got a very close relationship established last year, and through that collaboration they have brought together obviously AWS with SKT and us to build this. We have a telco focus, so I'm part of our telecom industry business unit. We do understand the industry and the use cases and the value that we're trying to deliver, and obviously that aligns with what SKT is trying to build around their use case requirements. They provided the data, and they also provided a degree of AI expertise. SK Telecom have been deeply immersed in training and fine-tuning models since the advent of the transformer architecture in early 2020. In fact, they were actually on the bleeding edge there. So really great collaboration between all three parties, and I think some really good outcomes have come from this. So now Eric is going to talk through his point of view around this collaboration.
SKT has deep domain expertise. We have language expertise. We know how to benchmark these models. And so in this process, that's the bottom half of this diagonal. SKT was in charge of, responsible for the data, how to actually construct the data, how to actually verify the data is high quality, and the benchmarking. What are we measuring? How do we actually measure this? On the flip side, the upper half of this quadrant is the responsibility of big tech, in this case Anthropic. That's the model tuning itself. How do we do the fine tuning? How do we do the RSF? They're experts in models, they're experts in algorithms, and so it was only natural to divide the work this way. But that's not to say that we just threw data over the fence, prayed, and said, please build us a model. It was a very deep collaboration where we were giving input. They'd give us data input on the data, they'd give us input on the benchmarks, vice versa. We'd give them input and feedback on, should we tune the model this way? Should we tune the model that way? When do we actually play RSF? So the point I want to highlight here is it was a very deep collaborative effort, co-development versus just throwing money or data over the fence and praying and hoping we get a good result. We actually were working with a development team, in this case from Anthropic. What does that development team look like? We had the privilege of working with a prompt engineer. We're still working with him, but he gave us really good advice about how to really optimize the prompt for these Anthropic models to squeeze out that last bit of a performance. Aside from that, we needed someone to help us fine-tune the model, so we got access to a fantastic researcher who had a lot of expertise in the supervised fine-tuning and the RLHF, meaning that we had a higher chance of success because instead of just going in blindly, this person had expertise, how to use the data, how to actually squeeze out results, and so that was helpful as well. Aside from that, surveying the model, which we'll get into a bit later, is super, super important. And so we got access to infra engineers as well. These are the people responsible for optimizing the model, making sure the model is running perfectly, making sure that we're actually serving the model on GPU specifically. So that helped as well. If you remember the LM capacity index, that goes into the speed and cost argument. We needed these people to help optimize those two aspects. And the final aspect was a solution architect. Solution architect is largely responsible for there's a lot of cookie cutter templates, but not one template that rules all. And so the architect made recommendations about how do you actually connect the retrieval system? How do you connect the back end? What does the flow actually look like? And so again, it may seem trivial. Again, there's a lot of things like agent bench or agent task that has these sort of pre-made frameworks, but having someone with boots on the ground that could actually help us optimize this and help us really find that solution that worked for us was another key differentiator. You'll notice on these slides I didn't actually say how many people. That's not the important thing. The important thing is that we got full-time resources dedicated to this project of these various different roles, which again helped drive this project forward and make sure that we were, one, successful, and two, completed on time. The sort of things we talked about, one, for prompting. Prompting may seem very cut and dry, but for us, we have a lot of tasks. If we end up doing these sequentially, as in calling out task A, task B, task C, the costs really add up. It's very, very slow. And so we worked on something called the mega prompt, where we optimized the prompt for calling many tasks at once, again, to improve speed and to optimize costs. Aside from that, fine-tuning may seem trivial, throw data at the problem, get a model, but that's not the case. How do we actually mix this data? How do we actually learn? How do we actually do the supervised fine-tuning? There's a lot of methods. You can just dump the data and tune. Those don't tend to work very well in practice. And so we ended up on curriculum learning, which just like humans learn from elementary school to middle school to high school, you can tune a model in a very similar way. So we start with the easier tasks. We work our way up to medium and then finish with the hard. And so that may seem very trivial or very easy on paper, but doing this really moved the needle and got us much, much better results. Aside from that, I did mention the solution architect. The person who was responsible for that really helped us with RAG. RAG is retrieval augmented generation. It's a key component to the system, make sure that you're not hallucinating, you're not lying, that you're telling the truth. And so they helped us optimize the system, design the system, making sure that we were not making too many calls or too few calls, calling out to the proper knowledge. So that really, really helped as well.
All right, so we talked earlier about the application of generative AI to what we call high-value workflows. So I just want to break down some of the components of high-value workflows and how generative AI can be used to optimize those and how that really turns into value for the customer. So this is a kind of fairly typical flow with generative AI integrated into the journey, if you like, in engaging with a customer care organization. So if we start towards the right with ACW, which is after call work. So this is everything that the agent does after they've hung up the call. So generally after a call, they will summarize the call, what happened, what actions were taken, was the call resolved, for example. They'll go through an activity called assigning a disposition. So generally there'll be some kind of drop down. They'll say the disposition was A, B, or C, and that really is to kind of classify the call into some kind of issue so they can actually analyze it later. So all these things take time and effort for the agent to complete. While they're doing that, they're obviously not taking calls. But as part of this, there's a lot of information that could be mined at scale. So once you start getting millions and millions of calls and you start analyzing these, then you can start seeing patterns. So, SK Telecom love to talk about pyramids. We love to talk about flywheels. So the flywheel effect here is taking that information and using the flywheel to feed that into the area that you'll see on the left with the first call resolution, where we can actually add that intelligence to the bots so they can understand what customers are calling about, how those issues were addressed, maybe what actions were taken or what APIs were called. So this is not all just about dipping into a knowledge base and getting the right answer. When Eric's talking about the fine-tuning of the model, part of that is defining what the actions to be taken are. What are the APIs that would be called to maybe actuate something or something to that effect. So it's more than just information, it is action as well. So moving to the middle, AHT is average handle time. So broadly that means how long the call takes. And broadly, telcos want, or any call center wants those call durations to be as short as possible, which means that you have answered the customer's question, you resolved the issue, you've been efficient and effective, and it means, again, you can move on to other calls around your productivity. So for context, a tier 1 in North America, if you can save an average of 1 second per call on average, you're going to be saving about $3 million. So if you can shorten a call by 10 seconds through AI and automation, at that scale, $30 million saving per year. So again, you can see how optimizing this agent assist call flow can very quickly give you a step function increase in results and value. The alternative to that in this specific flow with a generic model or a general model that's not fine-tuned, you would be sending a lot of information in the context, so that's going to cause some latency and slow down the responses. It's not going to understand the domain knowledge, the semantics, the actions to be taken. So you're probably not going to get accurate or deep enough responses, which means that your agents can't pass the right information on to the customer. And if you think about this, over time, agents are going to become dependent on AI for this workflow. So if the AI is not giving them the right responses, the right answers, the accurate responses, they're not going to have the wherewithal, if you like, to understand that this is the wrong thing to say. They become very dependent on it. So it's a very critical workflow for telcos. And then FCR, first call resolution, you want to get the right response to the customer, you want the right context, and really you want to capture that before it actually hits the human. So when we talk about that flywheel, we're adding intelligence to this front-end chatbot so they can actually understand this, the intent of the call, the action to be taken, the information needs to be captured so they can service the customer. All of this rolls up into CSAT, customer satisfaction score, net promoter score. 20% increase in that. That translates into significant revenue for telcos. So what that really means is that your churn number is reducing because your customers are happier. Customer lifetime value is a function of churn. So the lower your churn number is, the longer the customer lifetime value, the more revenue those customers are going to generate, right? So this is what all rolls up into what we call high value workflows. And generative AI, when applied to these with domain specific, task specific knowledge, can really transform this. So, and we're starting to see like results broadly in this space. There's a great paper by Laura Land that outlines 10 different foundation models across 31 different tasks. So ultimately 310 different models. And on average, they outperformed the base models by 34 points. And on average, they outperformed GPT-4 by 10 points, right? These are small, they're Falcons, the Mistrals of the world, but they are optimized against this. So generally the concept is applying your data to these high value workflows will give you a step function increase in value. And the other thing, hopefully you're picking up here is like, we talk about evaluations. You'll see new models released. You'll see an evaluation. We did it this week with our Nova models. We compared them against other models. But ultimately, you need to translate this into business value, and you need to apply it into the business, right? So a Rouge score really doesn't mean that much to somebody in the contact center. What's going to be important is that you've got a model that's got low latency, and it's got high accuracy, and it's got very limited or no hallucination, right? So these are the things that are important in this world. So we heard AT&T talk at the TM Forum event in September how latency and accuracy are the key features of generative AI that they will not compromise on. And if the model is less than 95% accurate, then they don't see value in that model because they don't want a model that is giving them bad information. So again, we like flywheels. So when we start talking about foundation models, the transformer architecture, at the end of the day, it's making predictions. And AI has made predictions more accessible to humans and human businesses. So with that, we make more predictions. Now, making more predictions means you make better decisions as opposed to gut or intuition. And we see that humans become a higher value, higher order part of that. So you're using human judgment to validate those predictions. And ultimately, this makes them more accurate with that feedback loop, and those decisions get even better. You capture data on this, you refine it, you keep fine-tuning and optimizing the model, and you get better output. So this kind of value flywheel with AI we see emerging now within the context of fine-tuning these models. So now we're going to let Eric talk through how they use data and some of the results and outputs that they saw of the TelClaude model when applied to their business.
So I've spent a lot of time talking about the what and even the how. So let's talk a little bit more about the data, which people are probably very curious about. As I said, over the past year, I spent a lot of time thinking about what is the telco domain? What does this actually mean? And so we ended up coming up with two data sets that we feel are very valuable. One is called TelTask and one is called TelInstruct. So if you look at these slides, the TelTask dataset is the one in navy and the TelInstruct is the one in teal or light blue or whatever that color happens to be. And so TelTask is meant to increase or enhance the capabilities of the base model. And so we focused on tasks that are very omnipresent across different use cases. So a common feature would be summarization. You need to take in a lot of information and be able to condense it into a digestible form. And so we spent a lot of work on summarization, not just of documents, but of conversations. And so the input is typically a call log conversation between a customer service agent and a customer, and the output of this data set is a summary. And so the difference here is it's not just summarizing the key information, but it's very action-packed, it's very detailed, it's very specific compared to normal summaries. Aside from that, as I said on the first slide I showed, customer intent is also very, very important. We need to know why people called so we can route to the proper APIs in the backend, or we can even route to the right agent. And so we spent a lot of time looking at intent. What are the intents people are calling about? What do we actually need to take action on? And so that's the second data set I'd like to call out. The other one that's a little bit different is topic. And so you may be thinking topic, so what? But we do a lot of post-call analysis on our calls. Why did people call in? What are the hot button issues? What are the trends? And so topics in this case take in a conversation again between an agent and a customer, and we come up with the most 5 topics based on that conversation. Difference between normal models is you may get very generic topics, as I'll show you very later on about the conversation. We're again very specific, very action oriented, and so that's the differentiator there. Let me dive into TelInstruct. So in TelInstructing and learning these capabilities, these tasks is perfectly fine, but the whole point of doing this project was to have a deep knowledge or an expertise about the telco domain. And so the TelInstruct dataset is meant to instruct or teach the model about the telco domain, what's important. there's two key data sets I want to call out here. One is MRC, or machine reading comprehension. It's very important not to just retrieve documents, but understand the contents of these documents. And so we put a lot of effort into, again, focusing on documents. What's the main theme of this document? What are some questions that people may ask about this document? And tuning the models to, again, reason about documents. The other data set that was important was, I keep calling it retrieval. So a lot of the actions we do internally is searching for knowledge, searching for documents. And so we put a very concerted effort into building a data set to teach the model about how to search for documents, and more importantly, how to ground or how to reason about the generated content that you're going to use to respond to this question. So it's not just generating a response, it's looking at what you got from the retrieval system and actually generating a response based on that. So it reduces hallucinations. It was super, super important. And so we put a lot of focus in those. And so when you combine TelTask and TelInstruct, you get a model that's really good at the tasks that we care about, for example, summarization, and you get a model that's now an expert in the telco domain because it understands documents, it understands the actions that need to be taken within the telco domain. And we worked with Anthropic over the year, and we saw fantastic. So when I talk about telco expertise score, that can be seen largely in this red. And so telco expertise score comprises of 5 at this point tasks that are very important for us. One is, as I said, summarization, super important. Another important task is planning, being able to take a complex query, break it down into subtasks, and take action on each of these tasks. And then, of course, why we're doing this model, response appropriateness is also very important. So you combine these tasks and you get a score, and then the overall score is the telco expertise score. So if you look at the blue bar, that's the base model. When we started with Anthropic, that was Claude 2. By the end of the project, it was Claude 3.5. But you'll still notice that even with tuning, we're seeing a marked improvement compared to the base model on the tasks we actually care of. If you look at year over year, we saw a fantastic 38% improvement from the base model just by tuning it on telco expertise score, which is a huge improvement. It went from non-shippable, non-workable to very shippable, and we can apply this to products and services. Aside from that, I love automated evaluation, but I don't actually trust it. And so we asked the end users, which are customer service agents, to rate this. The top score is 5, meaning this is the best thing since sliced bread. The bottom score is 1. And we said internally, if everything is above 4, this is very shippable. If it's not, then don't bother shipping this at all. And you notice for all the tasks we care about, the summarization, for the intent, for all these tasks, they're well above 4. The average is about 4.5. You'll see some 4.6. But largely satisfaction, this is the satisfaction of our end users, is now over 90%, meaning that we can actually ship this. So we went from mid-3s before we started tuning to well above 4. So this is also a massive improvement. If you do the year-over-year improvement, it's an improvement of 73% on the actual customer satisfaction, customer being the customer service agents here. As you can see, the 90% customer satisfaction score really shows 2 things. 1, that the fine-tuning was very effective, and 2, that this project was worthwhile doing, and doing something similar going forward for other domains makes logical sense. So it was a huge win in our book. We spent a lot of time on trust and safety. And these 2 things are very important because we have a brand image and reputation to uphold. If this model outputs responses that look very good, but they're lies or hallucinations, that's a huge issue. On the flip side also, when people call in, they're either bored and they want to talk about things that are non-relevant, or they're drunk and they're swearing, and so this is a huge burden on our customer service agents. And so for trust and safety, largely the focus was on how can we improve the lives of our agents, how can we avoid calls that are out of domain or off topic, how can we make sure that we're not hallucinating. The focus was all 3 of those aspects. And so we have a fantastic safety and trust system that's comprised of 3 different components. The low-hanging fruit is you can do some keyword matching or phrase matching to remove things like swearing or remove things that are out of domain. So that's the easy part. That's the part that's very updatable. It's very explainable. Aside from that, we also have a model that's very good at detecting these things. And the model is fantastic for things outside of keywords. There's a lot of sarcasm, there's a lot of context that's needed. And this model is able to take in context and have a deeper understanding of, oh, this does not look like a safe issue, or this is a trust issue. So that's been a boon as well. And the third aspect is these models are very teachable or instructable. We spent a lot of work on prompting. How do we actually prompt to detect these issues? And so that's tapping into the power of the telco large language model, but for a different domain. And so again, the focus here was not external, this is largely internal. We want to improve the lives of our customer service agents. And so this system is rolled out and gotten really rave reviews. You have the current state of affairs before the Telco LLM. The customer agent is stressed. They have a lot of time pressure. They have a lot of pressure. People end up quitting very, very quickly because it's honestly a thankless job. After we've rolled out this technology, these use cases I'm going to talk about in the next slides, you'll see the image on the right. You get these double thumbs up, which is great, but much better job satisfaction, much less stress, and much less likely to quit because, again, you have these support tools in place, whether it's trust or safety or whether it's the telco large language model. So it's a huge shift. And I also want to be clear that we're not replacing customer service agents. This is meant to augment their job. So let's talk about use cases. So that's the model itself. Obviously the model is fine, but rolling out use cases was the main focus, why we're actually building this model in the first place. And so we're calling this the contact center AI, and there's two use cases I'm going to talk about. One is the real-time assist, and the other one is the post-call. So I'm going to talk about post-call first, but largely the process before this model was rolled out was entirely manual. So after a call, a customer service agent would have to do some transcription, would have to do some summarization, assign topics. It's a very manual, burdensome process. And so the whole point of this was to automate this process as much as possible. There's still a human in the loop. The representative will still actually go check this looks good or edit results if they're not looking good. But again, we wanted to automate that to free up some of our representative time. The other use case is real time. During a call, a customer service agent has to search a lot of documents, read a lot of documents, understand a lot of documents, and then formulate a response. Again, it's a very manual process that's error prone. And so we wanted to automate this with something we're calling AI search. Largely, we search in the back end for relevant documents, and then we use these documents to ground or to generate a response that our customer service agents can read off the screen. If they like the response, they can read it. If they don't, then we have citations to these documents. They can reference the document. So it automates the search process to a certain extent and the response generation to a certain extent. Again, the whole point is to make our customer service representatives' jobs easier, make them happier at work. And so that rolled out back last month in October, and the post call is now rolling out. People want to change their names for whatever reason, and so they call up or ask, how do I change my name? And so previously the customer service agent would take this query, how do I change my name? They'd query our backend, they get about 2 or 3 documents, they'd have to read the documents, understand, and then surface the result. With our new system in place, the real-time assist, largely we do the searching. So we have document 1, document 2, which both describe how you can actually change your name. And then the model itself refers to these 2 documents, coalesces the results, and creates this generated response about, well, you can either call to the customer service person that you're doing now, you can visit us online, or you can go to an offline store. So we give the user options. And we also do some highlighting so the user knows sort of what to actually highlight, what's actually important. And again, this is all cited, so if the representative wants to click on the document and get more information, they're more than welcome. Let me show you a couple examples from the post-call, what the actual output is meant to look like. These are very illustrative examples, but they drive home the point. So I did mention summary and why it was important, but here's the conversation. A person calls in, they call in about their bill all the time. Why was my bill too high? How can I change my bill? So that's the gist of the conversation. The summary at the top is from a generic large language model, and you notice that yes, it gets the main points, but it doesn't mention any price points, it doesn't mention any plans, it doesn't mention anything about discounts, and so it's just too generic to actually be useful. The summary on the bottom is from our telco large language model, TelClaude. You'll notice that 1, it mentions numbers, 2, it mentions how to actually get discounts, and it's a very, as I said, decisive, action-packed, specific summary. So if a customer service representative looks at this summary, they know precisely why someone called in, what actions are needed to take, and so it's much more useful to them than this generic summary that you see at the top. We get a lot of calls about roaming. And when you roam, you're going to go to a country, there's a lot of different plans. So the flow is typically, where are you going, what plan do you need, and that's how the flow goes. And so again, we can compare a generic model versus our TelClaude. The generic model is at the top in red. Again, very non-specific, just mentions roaming, some generic terms that, again, the base model is very good at extracting, but not very good at explaining. TelClaude, on the other hand, is very specific. What countries are actually going to, what roaming plans needed. Again, so the agent can look at this and say, okay, this person called in for this reason. And so when we actually do some analysis, we can see where people are going and what plans are actually going. It really helps us with trend analysis. So again, the top is too generic to be useful. The bottom is very specific, very task-oriented. And so that was very helpful to our agents and to the people actually using these services. So we're doing a lot of work on use case expansion. Use case expansion is largely threefold. So one is different domains within the telco purview. So a lot of work on marketing and network. Marketing, we have T-Store, which is our flagship store. A lot of customers come in, but they have to chat with a chatbot, or there's online consultation. So having an assistant to, again, inform people about products and services, recommends products and services is a huge need, and so that's become a focus area. For networking, it's almost the same thing. If you look at networking, it's I have these issues, how do I solve my issues? Or I have a question about a product or service. So same thing, an assistant for networking is also a huge need internally that we're currently focusing on. Aside from that, I did mention previously that internal operations is one of the huge focuses. So there's two areas there. Our legal team gets way too many inquiries. People upload forms and say, is this actually legal? How do I actually do this? And so automating that review process to a certain extent, if not actually automating some of the document generation processes, is also a huge focus. Not to replace people, but to make their jobs easier and allow them to focus on the really, really intricate cases versus the generic ones. Aside from legal, another huge internal process is PR. I always make this joke, but I think it's actually half true. We're probably one of the world's largest PR firms. We crank out PR like no one's business. And so the PR firm, or our PR org, is very, very busy cranking out copy, actually writing articles. And so a lot of this can also not be automated per se 100%, but you can automate a lot of it and then just have human review. And so we focused on building a PR generator, so you get the document out and then a person reviews it for tone, style, and content, which means we're much more efficient in getting PR out the door. We also have a huge internal charter to focus on B2B, or business to business. And so we've started working with partners in finance, in manufacturing, and in the general sector, or the public sector. And largely, as I said, there's no framework, one framework per se, but we've done a lot of work optimizing our retrieval system, optimizing this model. So we want to take this template and apply it to other industries or other sectors, and again, sell it to other businesses. So these are the three main focus areas, but again, we want to expand the purview of the telco large language model to be applicable to other use cases and other domains, since we feel like we have a winning recipe here.
All right, we'll move to start closing this out. But just to close this out, we want to start just summarizing why, why SKT chose to collaborate with AWS, and ultimately Anthropic. And a lot of these are kind of, common capabilities that we have across AWS. So within this environment, obviously, scalability and flexibility is important, right? The ability to scale up, scale down, provide a consistent and predictable experience within that environment. We do have scale. I think this number is still correct. 34 regions, 108 availability zones across the world. So certainly the broadest infrastructure of any cloud provider. And within the context of fine-tuning, using private sensitive data for SK Telecom and using that to fine-tune the models. Obviously, privacy and security is paramount. So it's built in from the ground up in Bedrock and any AWS service. So SK Telecom can be assured that their data and any transactions are secure in the environment. And this is a managed service. So Amazon Bedrock is a managed service, which means that we take care of all the infrastructure. We provide all of the tooling, all of the guardrails, all of the knowledge bases, all of the evaluation, all of the capabilities. So all of that is available through what we believe are a curated list of the top models out there, all accessible through a single API. So as Eric wants to kind of scale things out across multiple use cases, it's readily accessible with all the tooling through a simple API. So let's close this out, just hearing from Eric and his perspective on why AWS.
Tuning the model is one thing, rolling out use cases is another. But when we actually try to productionify something, it gets very, very complicated. And so relying on AWS expertise, they have some of the world's best infrastructure. They have a lot of really, really smart people. And so it was a very collaborative effort between AWS, Anthropic, and SKT to actually get this model into production. As I said, Anthropic is very good at modeling. AWS strengths lie in their infrastructure being able to scale it. And so we worked with AWS and worked well with AWS for a couple of reasons. One is scalability. AWS has huge expertise in that. That being said, we may not have a million queries at once, so being able to scale up and scale down was very important to us, and AWS did a fantastic job of offering that and working with us to right-size it for the use case at hand. Aside from that, reliability is also very important. This is a production service. Any downtime has huge financial impact, and so AWS has SLAs or service level agreements in place, making sure that the model is up as often as possible, and if it goes down, having guarantees about when the model will go back, how much they're going to respond to it. And so that was a huge win in our book as well. And the last aspect here is, again, I want to highlight the collaboration. It wasn't just AWS doing this thing in a vacuum. Huge input from SKT, huge input from Anthropic. Anthropic knows their models better than anyone, so they were very helpful in how do we actually optimize this model, how do we reduce latency, which are all things we needed to get these use cases to market and surprise and delight our customers. So AWS is fantastic supporting Bedrock. And so there are 3 key lessons learned here, or takeaways. One is, because we're now faster at responding, our customer experience has improved. Customers are much more satisfied because they're getting responses faster. Korea is a very now. Why did that not happen 5 minutes ago society? And so getting faster responses that are also accurate was super important. So that moved the needle. The other one is response uniformity. Before, every agent had their own style, had sort of how they wanted to spin this. Now with this technology, we can unify the user experience by making sure that responses are as unified as possible. So if user A and B call up the same issue and they get 2 different responses, that's a bad user experience. But again, with this technology, we can now make sure that the responses are the same for each query. So that helped a lot as well. And the third one is for the actual customer service representative satisfaction. Now that they have this technology in place, the ramp up period when we hire someone is much shorter because, again, they have augmented technology to help their job. And their burden is also less because they can tap into this technology and make sure that they're not stressed or not feeling time pressure at work. So it's a huge win on all 3 of these fronts, and we're very happy to have rolled out this technology.
And with that, we'll call it a wrap. Thank you. I appreciate you all staying. Thank you.